Alright, so a couple of channel updates. Firstly, I got a microphone, so hopefully that will end the comments of me whispering or that's not loud enough. So hopefully from now on it'll be consistent audio and you guys will be able to hear everything. Secondly, I changed the kind of camera setup, so now I'm using my phone here for just a bit of a better output for like these face cams. So yeah, computer is no longer going to be for the webcam. I'm also starting a new series, which I'm going to try to make a video about once a month, about summarizing this book, which is designing data-intensive applications. So hopefully I can make one video a week about summarizing each chapter, starting from chapter 2. Other than that, this book is a 4.7 on Amazon, and it's a must-read for any beginner to medium level developer. If you search up books on programming or books on web development, on app development, it's one of the first programming books that comes up usually. So that's why I'm summarizing it, because it covers some key concepts that should be interesting to most of my audience. So this book has one key principle that I often endorse on this channel, and that's to understand the inner workings or how things are working under the hood. And this book tries to do that with all the things that you take for granted and that you use, especially in databases. So it covers actually what are the pros and cons of different databases, their query languages, how they work under the hood in terms of the database implementation, scaling databases horizontally or vertically, stuff like that, key terms that at some point in your web developing or app developing career, you're going to have to know and understand in order to build applications that people actually use and not just for side projects. So that's kind of what the book is going to explain in, I think, 12 chapters actually. So basically 2 goals of this series. You guys don't have to read the book. You don't have to read the 400, 500 pages. You just get all the information summarized. And I also understand it better because I've had to explain it to you. So let's get into chapter 2. Chapter 2 is about data models and query languages. And the book starts by making an interesting example that most applications are built by layering one data model on top of another. For example, as an application developer, you look at the real world and model it in terms of objects and data structures, which can be modified by using APIs, which you have also written. When you want to store those data structures, you store them in a general purpose data model, such as JSON or relational databases. The engineers who designed that database decided on a way to represent those general purpose data models in terms of bytes in memory. On the lowest levels, hardware engineers have figured out a way to represent those bytes in terms of electrical currents. The takeaway here is that each layer hides the complexity of the layer below it. And chapter 2 is all about comparing general purpose data models for data storage and querying. It will cover the relational model, the document model, and the graph models, and compare their uses, advantages, and disadvantages. So let's start comparing SQL, which uses the relational model, and NoSQL, which uses the document model. The relational model was a theoretical proposal by Edgar Codd in 1970, which at first generated a lot of skepticism, but by the 1980s it was widely adopted and its dominance has lasted 25 to 30 years. NoSQL is the latest contender of the relational model and was born in the 2010s. NoSQL databases try to solve a problem sometimes referred to as impedance mismatch. Basically, application development uses object-oriented programming languages, whereas data storage is done in tables with rows and columns. This leads to an awkward translation layer between objects and code and tables and databases that is commonly known as an ORM. Alright, so we know that one of the benefits of NoSQL over SQL is the fact that it solves this impedance mismatch. The way we store data in the document-like style model is more similar to the way we code in our applications. It looks more similar to JSON, which is what we use often. Another benefit of NoSQL over SQL is something called locality. When a document is queried from a NoSQL database, all of the information is stored in one place. And that makes it a lot faster than in an SQL database, where if we want to get the information, we might need to make multiple joins on different tables that could be in different databases. So that's another advantage, is that it's much faster for reads. So right now, it sounds like the document model is just better than the relational model because it resembles the coding language we use and has better locality. My own piece of advice: it is almost never the case in computer science that one system is always better than the other. Everything has its pros and its cons. The resemblance NoSQL has to programming languages in the majority of applications is just a straight up pro, but the better locality comes with its cons, as we will now see. Imagine we have a document with a deeply nested structure, like for example a person who has had multiple jobs, which were at multiple organizations. And having all the information in a single document is awkward, since you need to access the nested structures through a long chain of properties, usually in a way that we humans find difficult to read. In contrast, SQL splits people, jobs, and organizations into their own tables and then connects them with a foreign key upon querying, laying all the data out in the open in a human-readable way. So better locality leads to better performance on reads, but poorer performance on modeling interconnected data, which means NoSQL is better for reads, and SQL is better for modeling very interconnected data with many relationships. The last domain where SQL and NoSQL databases differ are schemas. NoSQL databases usually don't enforce a schema, which can lead to arbitrary key value pairs stored in the database, whereas SQL databases can only store data that has been defined in the table. This leads us to the definitions of schema on read and schema on write. NoSQL databases are defined as schema on read, as the schema is implicit and only interpreted when read. Basically, the database does not enforce anything, but the application code still understands the shape of the data. SQL is schema on write, since the database enforces a certain schema and won't allow data to be stored unless it conforms to the shape of the table it's being inserted into. Schema on read is like dynamic runtime languages, and schema on write is like static compile time languages. Alright, so that kind of covers chapter 2 of designing data-intensive applications. The book covered other things in this chapter which I didn't summarize in the video because I thought it was less important for beginner developers or indie developers. But in the video or in the book, in the chapter, they talk about the graph data model and how you can model other data that's highly connected using graphs with edges and vertices and nodes, kind of representing the documents or tables in relational databases. Another thing that I wanted to point out is, although I've been saying SQL and NoSQL a lot, SQL is actually the query language used by relational databases. And NoSQL is just a general term for databases that aren't in the relational database. So each database has their own query language, and SQL just happens to be the most used query language for relational databases. And NoSQL databases or document-based databases, whatever you want to call them, have a set of their own query languages that the book discusses. And there's also pros and cons of those query languages, including whether they're imperative languages or declarative languages or some kind of hybrid in the middle. So I hope that's also a nice clarification, and I hope that also you guys learned something from summarizing this chapter, since it's supposed to be a must-read for beginner developers. Let me know if you enjoyed this first episode of the new series, and if people enjoyed it, I'll continue it. Otherwise, we just go back to what we were doing.